this video, we are going to be discussing strings in the C++ language. Simply put, a string is a data type that stores input as any collection of characters from the keyboard. Anything that can be typed at the keyboard can be thought of as a string. The syntax for declaring a string variable is much the same as it has been for creating variables of other data types. That is, we use the word string to declare the data type of our variable. We then provide a name for the variable, and if we so desire, we can then assign an initial value to be stored within that variable. Whatever we wish to be assigned to the variable var name needs to be encased within quotations, and it truly can be anything you can type, which includes alphanumeric characters, symbols, spaces, and punctuation. As always, we end with a semicolon. Until this point in C++, the data types we've learned about have been what are called primitive or built-in data types. However, in the C++ language, strings are not a primitive data type. If you noticed that I used a different color for the word string right here than I have in videos past, normally this color is a dark blue if what we're using is a C++ reserve word. The word string is not a C++ reserve word, and in fact has to be looked up from a library. As opposed to the primitive data types we've seen in the past, strings are what is called a user-defined data type. This means a couple of things. Initially, it may seem like a downside, as in order to use strings, we need to include the string library at the top of our main.cpp document. However, something we have not yet seen that we will see when dealing with strings is the concept of methods, which are actions that we can perform on the variables that contain the string data type. These methods are really quite useful, and we'll see some examples of working with them later on. Now, data types have operators, and the first operator I'd wish to discuss with the string data type is the addition operator, which actually works to take two strings and concatenate them, which is to just place one string at the very end of another. The example code shown here defines two string variables, one called first name and one called last name. If we wish to put them together to form a string variable called myName, we can simply add them, and the result will be to output Sarah Jensen with no space between the two names. Remember that the computer is incredibly literal, and it will not put a space between Sarah and Jensen unless I explicitly tell it to do so. There are many ways to modify the code above to produce space in between the words Sarah and Jensen, but one such way is to simply add that space in explicitly as what is called a string literal, which is an instance of a string that we do not assign to a variable. Our very first program, which dealt with creating ASCII art, dealt entirely with string literals. Now, strings are a more advanced data type, and what's actually happening behind the scenes in the computer is that we are thinking of strings like a list of individual letters, the way that we think of a word as individual letters being put together to have a larger meaning. This means that each individual letter within the string has its value, what the letter or technically character is, and it has its position in line, which we call its index. While human beings tend to count things 1, 2, 3, 4, 5, the indices of a string, which are counting positions in a list, actually count beginning at 0 and going up through 1 less than the length of the string. One thing that we often do with strings is we wish to access one individual character or letter within the string. In order to do this, we use this bracket notation with the name of the variable preceding the bracket and the index of the letter that we wish to see displayed inside the brackets. So let's walk through an example. Continuing with the example from before, let's create two string variables, one named first name and one named last name. Let's then use a loop to walk through the letters of the first name string variable one at a time, displaying both their index I and the character value in that position. Now the index of the character is being referenced with our looping variable, this integer I. So first, we print that index value to the screen. We then ask for a space to be printed to the screen and to see the actual value in the first name string at the position I, we use the variable first name, square bracket, the position we wish to see the character of, followed by a closing square bracket. We then end the line. So this code provided in the for loop right here on the left produces the output over here on the right, where the character in position 0 is this capital S, the character in position 1 is the first A, the character in position 2 is the letter R, and the final character occurring in position 3 is that final A in the word Sarah. The next two things we may wish to do with strings is check for when two strings are equal or check for when two strings are not equal. This may be fairly straightforward, except in that it is important to note that things like spaces, punctuation, and capitalization are important when checking strings for equality. To demonstrate this, I've shown some code below that creates two string variables. One, the string variable we've had running in this example, the string first name, which has a value of Sarah, and another string called other name, which also has the value of Sarah, but the first S in Sarah is lowercase instead of uppercase. We then write some code to say if those two names are thought of as the same by the computer should tell us so by printing to the console that they are the same. If the computer does not think of them as equal, that is, if in line 11 the Boolean expression first name double equals other name evaluates to false, then we should print to the screen that these two things are not the same. Indeed, executing the code above results in the output they are not the same to the console.